Assalamualaikum and a very good evening. My name is Muhammad Niqkhan bin Roslan, and today I will be presenting about my home network case study. Now let's start with the introduction of the network. So the network overview. The ISP that is being used is Time Internet with 600 megabytes per second fiber optic plan, and there is a single router in the living room. So for users and device, there are a total of 7 residents and roughly 2 devices for each resident. And for the whole network, all the devices use Wi-Fi while only one wired device. And for the apartment details, it is situated on the fifth floor of a six-story building, and it contains three bedrooms, one living room, one kitchen, one toilet, a bathroom, and a laundry room. So the noted issues for the current network is dead zones around the kitchen area due to interference, and unconfigured router, meaning that the security is not secure, and finally a simple unencrypted file server hosted on the personal device. Unencrypted meaning that anyone can access it without any issue. Alright, so we're moving forward to the problem statement. First, we have network congestion, meaning that there's around 7 people and each of them have roughly 2 devices. So around 15 to 16 devices are shared to under one single router. And then next we have heavy internet usage for things such as 4K video streaming, large files downloading, or cloud gaming. And then next we have unsecured file server. Again, we have a self-hosted server on the laptop without any form of protection, so anyone on the same network can access sensitive files. Next, we have poor router security. So the router currently have default login credential and it does not have network segregation or guest network. And finally, we have signal issue. So Wi-Fi coverage is weak in certain area. I'll be explaining it after this. And then finally, we have which leads to drop connection and slow speeds around the dead areas. So our objective is to analyze the cause of network congestion with the goal to improve network performance. And then next we have to create a proper and secure server file hosting that is accessible within and outside of the local network. And then we want to implement a method to improve signal coverage to combat against dead zones to ensure consistent network performance. And finally, our objective is to implement security configuration that focuses on access prevention, network isolation, and encryption. All right, I will now be showing the hierarchical network design for the current network. So as we can see, there is only 2 visible layer, although there's actually 3 layer. We have the core distribution and access layer, but since we have only a single router, the router acts as both the core and distribution layer. So the core and distribution layer, we have a single router which acts as a Wi-Fi wireless hotspot where all the device wirelessly connect to the router, and we have one single device which is wiredly connected to at the living room. So one single laptop and the other devices are connected wirelessly on the access layer. Next, we have the physical network design. So let's start with bedroom 1. So bedroom 1, we have 2 devices that are connected through Wi-Fi, so they are connected to the wireless router over here. Bedroom 2, we have 2 more devices. This is mainly laptops, and they are connected also to the wireless router. And then for bedroom 3, we have a single one connected wirelessly to the router. And then in the living room over here, we have the wireless router by itself, situated top left corner of the living room. This is near the outside, so that signal won't be blocked, but it wouldn't matter because we are using cable to connect to the ISP. Next, we have the dead zone area. This is where the area where Wi-Fi connection will not be usable. It will be very slow. which is around the storage, bathroom, toilet, and a bit on the kitchen side also. That is all for the physical network design currently. So for the cables, since there's only one devices that is physically connected, we are using one single RJ45 cable to connect between the router and the 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 device, which is in this case is a laptop. And to connect the router to the ISP, we are using an SC APC fiber optic cable. And we have only one internetworking device, which is our router. Our router is a Huawei brand OptiX Star router. It has XGS-PON fiber, which is one of the fastest fiber internet, which supports up to 10 gigabytes per second. It has dual band Wi-Fi 6, meaning that it supports both 2.4 gigahertz and 5 gigahertz internet network. Again, it uses SCAPC fiber connector, and it has a total of four ports, which is 2.5 Gbps and 3 1 Gbps port. And to note, there it defaults to WPA2 with AES encryption for the Wi-Fi, and it contains built-in unconfigured firewall, so you can configure the firewall to make sure your network is safe. All right. Next, moving on, we have network traffic analysis. So for the network analysis, we are analyzing it to pinpoint how the network speed can be affected by the physical network design. So I am currently using speedtest.net, which is a website where you can benchmark the speed or download speed, upload speed, and the latency of your current network. So the method we'll be using is by taking average of 5 results, and each results are taking on each red dot. So let's say this is a room. So each dot representing each single result taken. So one result was taking on this corner, another result is taking in this corner, this corner, this corner, and the last corner. The last one is in the center. So this is to take the network inconsistency into account. And this is the results. We're gonna focus on the max and minimum. So the highest download speed, upload speed is around the living room, which makes sense because the router is situated over there. The bedrooms are also fine. So we have bedroom 1, 2, and 3, which has decent average, still usable internet. But when you go down to around the bathroom and storage, and to the toilet, especially the storage and the toilet, we see that the download speed has dipped to 27 and 22, and worse upload speed until the zeros. So around this area, the network is pretty much unusable. Alright, moving on to the network upgrade suggestions. So this is the hierarchical network design. So this is the suggested design. So now instead of having one router as acting as both the core and distribution layer, we have a single router that acts as a core, and then it is connected to all other devices over here. We have 3 switches and 1 mesh Wi-Fi, and the last one over here is a file server. So all of these are distributing network to each of the rooms, and including actually no, each of the rooms, right? So bedroom 1 has 1 switch, bedroom 2 so to 1 switch, bedroom 3 1 switch, and then the mesh Wi-Fi is for extending the connection, especially on the dead zone. And then finally we have the server. File server will be used as a form of file access for all the devices connected to the network. And then so the improved hierarchical design. So the router load is reduced by taking advantages of the internet port to distribute the network. So wireless network load is also reduced with the help of mesh router on the distribution layer. So at first we have one router dealing with all the Ethernet and all the Wi-Fi's. Now we have the mesh Wi-Fi. So instead of using only Wi-Fi, the main Wi-Fi, main router as the Wi-Fi, users can also connect to the mesh Wi-Fi. And and the fact that we split it into three distinct layer, it allows us to easily troubleshoot, upgrade, and scale the network. Uh, Next, we have the physical network design. This is the suggested version. So we situated the file server near to the wireless router, and we want to elevate the wireless router so that it would not be blocked by this table over here, because this is on the ground. Same goes to the switch. All the switch are situated on each room on a table, so it's easier to access. And then finally, we have our new addition, which is the mesh Wi-Fi situated near the storage area. They will be physically connected from the router to the mesh Wi-Fi, and it will prevent dead zone from occurring, allowing users to interchange between different networks when they are around the dead zones. Other than that, we have changed it so all the devices are connected through the switch. Not all device, but mainly the laptops that allows for that has Ethernet ports. So Ethernet ports are directly connected to the switches. Same goes to bedroom 3, bedroom 2, and bedroom 1. So the addition of centralized file server, it simplifies the file sharing for all users, fast access for all users, and it is placed close to router for easy connection and low latency. And again, wireless optimization, we elevated the routers to reduce the wall interference caused by walls, the tables, and then the mesh router to remove the dead zone and ensure strong wireless coverage throughout the whole apartment. And then wired laptop connection, the reason is to ensure high speed stable access when doing network intensive tasks. So these four are the suggested internet networking devices. We have in Huawei OptiX Star, which is the same one. We don't need to change it, but we do need to change the configuration of the router. We have a switch, a TP-Link LS105G TP-Link switch, a Huawei Wi-Fi mesh, a Dell Optiplex 7040. So for the Huawei router, it is still the same, but we want to implement SPA and MAC IP URL filtering to ensure network is secure. So the flexible configuration is ideal for enhancing security without changing physical structure. So all we need is to configure from the router through the router IP address. Next, we have the TP-Link LS105G switch. So it has 5 gigabit Ethernet ports. So there's more room for more devices that can plug into the internet. And it has plug and play setup, meaning that you don't have to set it up. You just plug it in and you are directly connected to the network. And then the fact that it is quite affordable, it's around 50 ringgit per switch. So it is an affordable solution for scalability, and then it definitely ensure consistent performance for wired user. Next, we have the mesh router. In this case, we are using Huawei Wi-Fi Mesh 7. So it covers the dead zone. And one of the key features that is very good for this specific mesh is the seamless roaming across all mesh units. So when the network changes, when let's say a person goes to the dead zone, instead of getting cut off the internet, the mesh will seamlessly change the network to the Wi-Fi SSID, so you won't have any internet cut off. So you have uninterrupted wireless connectivity throughout the apartment. And finally, for the file server, we have chosen Dell Optiplex 7040. So it is equipped with Intel i5 6 Gen, which is a pretty strong processor, enough for the current use case, which is file server. and then it has 24/7 uptime. Since we do not mess with the server other than accessing it remotely, right? When we access it remotely, but other than that, it will stay on, unlike the previous setup where the laptop hosts the file. But since it is a laptop, people will be using it, and sometimes it needs regular shutdowns, so it won't be up for 24/7 time. And then finally, we chose this because of the multiple choice of storage expansion, which is 3 drive base and 1 M.2 SSD slot. 1 M.2 SSD slot will probably already be used for the OS itself, but we look at the 3 drive base. There are lots of storage choices, uh, up to 10, 20 terabytes of storage per drive base. So there's a lot of choose from, a lot of ways to increase the storage. That is all for the uh, internet networking devices. So finally, the conclusion. So the network analysis was able to identify the key issues in the original setup, which includes the poor network coverage, limited scalability, and inconsistent performance, and weak security. So these flaws were tackled by introducing a proper scalable network design. Implementation of mesh Wi-Fi helps eliminate dead zones, dedicated file servers to allow for reliable access, and enhancing the security measure by properly configuring the router. So this upgrade design provides a reliable, high-speed, and secure network suitable for the client state. That is all for me. Thank you.